Okay, we're ready now to talk a little bit more about, the recognizing the fact, is carbon dioxide the only greenhouse gas? We've said no, it's not. Any gas that has a stretch or a bend, vibrational modes that can absorb infrared radiation is going to be considered a greenhouse gas. We spend a lot of time, and you hear a lot in the news about the carbon cycle, about how we're disrupting the carbon cycle, we're increasing atmospheric carbon dioxide, but we want to understand, why do we talk so much about carbon dioxide and not talk about some of these other greenhouse gases? Okay, so those other greenhouse gases, of course, are the ones that are gaseous molecules that have asymmetric electron distribution and that are capable of absorbing infrared radiation, all right, which is most of the other gases other than the small diatomics, which dominate our atmosphere. Oxygen, nitrogen, and even argon doesn't have vibrational modes. So let's take a closer look at a couple of gases that are considered greenhouse gases. Methane and dinitrogen monoxide. Dinitrogen monoxide is also called nitrous oxide, and you should know the structures of those two gases, obviously, from what you've learned so far this semester. Methane, of course, you memorized, is CH4, and dinitrous or dinitrogen oxide or nitrous oxide is N2O. So let's take a closer look at a couple of those gases. Here's a table from your book comparing the concentration changes and lifetimes of greenhouse gases, okay, over time. And so you see the three columns at the top: carbon dioxide, methane, and nitrous oxide. And we have concentrations during pre-industrial times, then compared to the 2005 concentration, and then the average rate of concentration change from 1990 to 2005, and the global atmospheric lifetime. This means how long the molecule will last in the atmosphere. Okay, and so you can see pre-industrial concentrations of carbon dioxide about 278 parts per million, methane 0.7 parts per million, and nitrous oxide 0.270 parts per million. So there's quite a bit higher concentration of carbon dioxide compared to these other two gases. Also, you can see a change over time from the post-industrial revolution. It's up to 385 parts per million on average, methane 1.75, and nitrous oxide 0.314 parts per million. And so the thing is, even though it looks like this has doubled, but if you look at the change per year, it's such a small amount, the concentration change in the recent time from 1990 to 2005. We see that the rate of change is much, much greater for carbon dioxide than methane or nitrous oxide. So it seems like we're putting more and more of the carbon dioxide, a higher rate of carbon dioxide, into the atmosphere. And then the amount of time that it remains in the atmosphere varies widely because it's such a dynamic molecule and there's so many places for it to go. The methane and the nitrous oxide are easier to track, and methane about 12 years, so it's not very long, whereas nitrous oxide about 114 years. There's not a lot of natural mechanisms to remove nitrous oxide from the atmosphere. Okay, so that's part of the problem is that there's carbon dioxide we're putting more into the atmosphere per year, and it's mostly due to people. Methane, it leaks from the ground, from natural gas fissures and whatnot, and it's also a natural from the anaerobic bacteria produce methane. There's lots of natural production of methane that can occur. Nitrous oxide also largely from bacterial production.